All right, so let's take a look at the second point of collision theory, and it states that the collisions must occur in the correct orientation in order to react. So let's think about our one reaction here. We have carbon monoxide plus O2 forming carbon dioxide and a lone oxygen. So if we think about the Lewis structures of carbon dioxide, we'll get something like this. O2 will get something like this. And then CO2 will get something like this. So let's take a look at two different scenarios of what could happen. We'll label them A and B. And in this case, we're going to take our carbon monoxide and our oxygen, and we're going to say that they collide, but they collide so that the oxygen hits on the oxygen on the carbon monoxide hits the oxygen on the O2. Well, if you look at the Lewis structure of CO2, we see, and the difference between CO, we see that it's the carbon that needs another oxygen attached to it, right? So if you think about this collision, maybe it'll form like COOO, which is not really a thing. And so if you get this orientation of collision, there's no product, right? It did not hit in the correct orientation. Whereas if we flip this molecule, and now we say that this carbon hits this oxygen, it can form a bond with this oxygen, and then it can kick off this other oxygen, right? And so then we'll get our CO2 and our neutral oxygen by itself. So you can, and thus the product. So you can see that the orientation matters. And the more asymmetrical a reactant is, the less likely it is to hit in the correct orientation. Because if you have something that's perfectly symmetrical, hitting it on any side forms the same thing. And so here's just another representation of the above.